are constant regardless of the area of concern. Okay. Rule number 1. So what does this mean, right? Regardless of the size of the shaded area, I repeat again, regardless of the size of the shaded area, B and I are what? Are constant. Are we clear? If you were to look back in the formula, in bending moment, okay, where we have stress X is equal to mz over izz multiplied by y, right? You will realize that mz over izz is also constant regardless of your point of interest. What changes in this formula is what? What? Right? What changes over here? If you look at the bending moment equation over here, right? You realize that mz and izz are also what? Constant. Y is your what? Variable. Okay. So rule number 1 over here. V and I are constant regardless of the area of concern. Okay. So now we are going to go into this formula. So we know that this is a constant. And this is also a what? Yes. Now, this, what is the most complicated? Okay, not complicated. So let's look at this. So we know that Vy is constant. And then we look at Izz, which is equal to width depth cube over 12. Okay, so I'm going to get this diagram over here. And you guys are expert in finding what is Izz already, right? So we know that it's width depth cube over 12. So this will be equal to B, right? The depth, so we know that there's C over here. C plus C is 2C cube over what? 12. Okay. So when we write it out, it's 4/8C cube over 12. And then finally, this will be equal to 2 over 3BC cube. Okay. So the next one, we are going to find QZ, okay, which is equal to A y bar. Okay. Before I carry on, because the axis of interest is IZZ, it's important that we put that this is our width, and over here, this is our what? Our depth. Okay, because later on, when we do multiple axes, the width and depth will change. Okay. So now, let me copy this whole thing and we go to a new page. So QZ is the first moment of area about the what? Z-axis. Okay. So later on, when we have QY, this is equal to A Z bar. And QY is the first moment area about the what? Y-axis. Okay. So if I were to take this diagram out, I want you all to look at both of them. Okay. So for this case, the area will rotate about the what? The Z-axis. So what this means, the area will rotate about the what? Z-axis. Right? Moment is about rotation, yes or no? Okay. If we were to take IYY or QY, means the area will rotate about the what? Y-axis. So that's why the perpendicular distance in QY is Z. The perpendicular distance in QZ is what? Is Y. Okay. So now we are going to find QZ is equal to a Y bar. So what I like to do is I like to go by the width, depth, Y bar. So I repeat again, this is my width. And this distance is my depth. Okay. So what is the width? Okay, for this case, the width is B. All right. And then the depth, right? So depth is equal to, so depth, what do we mean by depth in the shaded area? So this is the area of interest. Over here, this is our depth. Okay. So the depth is C minus Y. And the Y bar, which is this value we want to find, is C plus Y multiplied by half. Okay. Is this clear? I know this is not easy to remember, okay? But you don't need to remember. But why is it? So this term over here is our width. This term over here is our depth. Those are straightforward, yes or no? But why is our width, our Y bar, C plus Y times by half? Okay. And, you know, sometimes you cannot remember stuff. I don't mean to be rude. I can't remember most of your name. At least I'm honest about it. Okay. But you can derive it. Okay. So how do you derive it? Okay. If you put this as 5, right? And you put this as 8, how do you determine this distance over here? And you know both the spacing at the top and bottom are the same. So how do you get that distance? So what do you do? Right? So you want to calculate your Y bar. So you know that your Y bar is equal to what? 8 plus 5 divided by what? Divided by 2. So 8 plus 5 is what? 8 plus 5, 1, 2, 3, 4, 13. And 13 divided by 2 is what? 6.5. Are we clear? That is how you get your what? You get your Y bar. Are we clear? Okay. Yes. Oh, you're just raising up your hand. Pentecostal position. Hallelujah. Okay. Anyway, I'm sorry. So from here, we have what? So we have QZ is equal to B over 2, right? And then we have C squared, and then we have minus Y squared. Okay. Now, again, math. You realize that it is C minus Y and not Y minus C. And the next term is C plus Y. I know it does not matter Y plus C or C plus Y is the same shape. Right? Same shape, different smell. But why is it C minus Y and not Y minus C? If you do Y minus C, what will happen to that term over there? It will become negative. Yes or no? Right? It has to be what? C minus Y. So in future, when you look at a formula like this, don't just like whatever. It means something. Okay? It means when you look at the first moment of area, the analysis starts from outside in. Are we clear? Okay, the analysis starts from outside in. Okay, so the analysis starts from the distance furthest away from the what? Again, the analysis starts from the furthest distance away from the centroid. That is why it is C minus Y and not Y minus what? C. Okay, so from here, rule number 2. Okay, rule number 2. Okay, the analysis starts from the distance furthest away from the what? From the centroid. Okay. And then from here, so we have make up 2 rules, and the third rule, as you all know before, rule number 3. The datum is at the centroid. And from here, we have rule number 4. Okay. From what we see from this diagram, the first moment of area cannot cross the what? The centroid. Okay. So in this form, they did not, because everything starts from the datum, first moment of area, and of course the datum. And later on, I'll teach you what will happen if they cross the datum. What must you do? Okay. And then the third thing that we have, we can draw, okay, which I did not draw earlier. This is the direction of your shear flow. So this is Q. Okay, so from here, rule number 5. is that the shear flow Q can only flow in one direction.